Isotopes. So I mentioned to you that not all atoms of the same element are actually identical. And this is where isotopes come in. Isotopes are atoms that have the same number of protons, but they have a different number of neutrons. They're going to have almost identical chemical properties to each other because they have the same number of electrons. So they didn't really cover this. Atoms are electrically neutral. So the number of protons with the positive charge has to equal the number of electrons with the negative charge. So if you change the number of protons, you'd have to change the number of electrons, because all atoms are neutral, they don't have a charge. But what could you change? You could change the number of neutrons. So you could have an atom of carbon. You could have an atom of carbon that has 12 protons and 12 electrons and 12 neutrons. Or you could have one that has 12 protons, 12 electrons, and 14 neutrons. The neutrons do not have a charge, and so they're not going to affect the number of electrons. If you change the number of protons, then you have to change the number of electrons. Chemical behavior arises from the electrons. So when you have two isotopes, wake up, computer. Okay, so the computer is back on now, but I don't remember what I was saying. Oh well. So isotopes, different numbers of same number of protons, different numbers of neutrons, identical chemical properties. And in nature, most elements contain mixtures of isotopes. So, you find carbon, and it's not just a single isotope. Most of the elements have more than one isotope. So, let's look at sodium. This illustration is showing us two different isotopes of sodium. So here's the nucleus. And inside the nucleus of this sodium atom are 11 protons and 12 neutrons. Because there are 11 protons, there are 11 electrons, and they're in this cloud outside of the nucleus. This is a different isotope of sodium. This one has 11 protons and 11 electrons, but it has 13 neutrons. The number of protons is what tells us which element an atom belongs to. What these have in common is they both have 11 protons. The number of neutrons makes a very tiny difference in them, but for most of the situations it's not important at all. So we have symbols to indicate the different isotopes, and most of the time we don't care about the isotopes, but occasionally we do, and so we need to learn what the symbol is. So this is the format for the symbol. Here we have X, that's standing in for the symbol of the element. So that could be Na or CO or any of the element symbols. And then on the left we have a superscript, which flies above like Superman, and a subscript, which goes below like a submarine. The A tells us the mass number. The mass number is just adding up the number of protons and neutrons. Those are the particles that have significant mass. And so we ignore the electrons, we just add up the number of protons and neutrons. And that has the symbol A. And Z is the atomic number, which is the number of protons. And this identifies which element it belongs to. Now, if it was my doing, I would have A be the atomic number. Wouldn't that make more sense? A for atomic number, and Z for the other one is backwards. Sorry. Examples. 2 isotopes of carbon. So in this symbol, we see the element symbol for carbon. Down in the bottom, we see the atomic number 6. And that actually is on the periodic table. We see carbon is element number 6. The whole numbers on the periodic table in the box with the element symbol tell us the number of protons that that element has in each of its atoms. So this one's got 6 protons. The 14 here is the total of the mass, the total of protons and neutrons. And so how do you find the number of neutrons? Well, you just subtract, and it's actually stacked up there so you can subtract it. 14 minus 6 is 8. So that means there's 8 neutrons. 8 neutrons, 6 protons. In this one over here, the element symbol is the same, the atomic number is the same, because it's a different isotope of the same element, but here the mass number is 12. 12 minus 6 is 6. So this one has 6 neutrons, and this one has 8 neutrons. These are both carbon atoms, but they're not exactly the same. They're going to act almost exactly the same. Any questions? So a certain isotope of vanadium, 23 protons, 28 neutrons. What's the mass number of this isotope? Well, the mass number is what? The number of protons and neutrons. So we need to take 23 and 28 and add them together. We have 51, right? So that's the mass number. What is the symbol for this isotope? V is the element symbol for vanadium. And in the superscript, we put the mass number that we just figured out. And the subscript on the left is the number of protons, 23. So this is the symbol for that particular isotope.